All right, let's jump right in. So, picture this scenario. You're a tech founder or maybe a lead engineer at a fast growing startup right here in the US. You've just integrated the absolute latest frontier AI model into your core SaaS product. The launch? Flawless. Your users across New York, Chicago, San Francisco, they're completely blown away by the natural language capabilities of your application. You're feeling great, but then the end of the month rolls around. You open up your AWS or OpenAI dashboard, and your stomach literally just drops. The bill is astronomical. Like, what actually happened here? Well, every single time a user asked your app to just parse a simple JSON file, or fix a quick typo, or route a basic customer service ticket, your system pinged a massive 70 billion parameter model sitting on some distant cloud server. Welcome to this explainer, where we're going to look at exactly how to fix that. We're exploring the edge AI revolution and showing you how you can escape this massive financial burden for good.
Here's our roadmap for today's explainer. First, we'll look at the cloud AI trap, then the edge AI arsenal. Third, we'll cover how quantization works, and finally, the smart routing strategy.
Section 1, the cloud AI trap, or the hidden costs of going cloud first.
So let's really unpack the problem here. For a while, we kind of all just accepted huge AI bills as these so-called API tax, right? But this quote brilliantly hits the nail on the head regarding what we've been doing. Stop using a sledgehammer to crack a walnut. I mean, we are paying premium, top-tier cloud compute prices for trivial tasks that, honestly, a smart calculator could handle. The era of blindly routing every single simple query to a massive cloud model, it's over. Because when you rely entirely on massive cloud-based large language models, or LLMs, you're basically fighting a losing battle on three very distinct fronts. First up, cost. It is the ultimate margin killer. In a market where SaaS margins are heavily scrutinized by investors, paying premium API credits for simple tasks is basically financial self-sabotage. Second is latency, the dreaded loading spinner. We all know consumers are naturally impatient. If your app takes 3 seconds to respond just because it's bouncing data back and forth to a server cluster in Virginia, well, the user experience is already ruined. And third, privacy. It's an absolute compliance nightmare. Sending sensitive customer data like personally identifiable information or healthcare records out to third-party APIs introduces massive hurdles with regulations like HIPAA or CCPA. We really need to stop fighting this losing battle and actually bring the intelligence closer to the user. Section 2, the Edge AI Arsenal, the 2026 heavy hitters. All right, let's shift gears to the solution. You know, running AI locally used to be a total pipe dream, but today, hyper-optimized small language models, or SLMs, are completely dominating the space. Comparing these three heavy hitters side by side, the metrics that truly matter here are VRAM and speed. First up is Microsoft's 5.4 Mini. At 3.8 billion parameters requiring only about 3 gigs of VRAM, this thing is your reasoning powerhouse. It's the model you reach for when you need serious logic, math verification, or complex reasoning chains. On a standard NVIDIA RTX 4090 GPU, which, let's face it, sits in thousands of developer rigs, it churns out around 300 tokens per second. That's incredibly fast. Next, we've got Meta's LLaMA 3.2, coming in 1 and 3 billion parameter variants. This is the prototyping champion. It requires just 1 to 2.5 gigs of VRAM, making it a perfect drop-in replacement for constrained memory environments, like your standard Office laptop. And finally, Google's Gemma. At under 2 gigs of VRAM, it is the undisputed king of mobile. Google optimized this specifically for their AI Edge stack to just sip battery life while generating surprisingly coherent language directly on iOS and Android devices. Section 3. How quantization works. The secret sauce.
Now, I know what you might be thinking right now. How on earth are we fitting billions of parameters onto a 3-gigabyte graphics card or a mobile phone? Well, the crucial piece of the puzzle is a mathematical magic trick called quantization. Formally, it's defined as a mathematical compression technique that shrinks AI model weights down to 4-bit integers, or INT4. As a developer or a tech leader, understanding how this works is absolutely vital for establishing technical authority over your stack. Let's translate that into something a bit more intuitive, so we don't need a PhD in mathematics to get it. Usually, an AI model uses 16-bit or 32-bit floating point numbers. Think of those as massive, uncompressed raw image files. They hold a massive amount of data, yes, but they take up a terrifying amount of storage space. Now, on the flip side, think of INT4 quantization as compressing that giant raw image into a highly optimized JPEG. If you zoom in 500%, sure, you might lose a microscopic amount of detail. But to the naked eye, it looks identical. And crucially, the file size is 80% smaller. It's a real game changer. So there are 3 main ways engineers are actually pulling this off right now. First is GPTQ. This is your go-to method for post-training compression. You take your massive model, run it through the GPTQ algorithm, and it optimizes the weights specifically so they run blazingly fast on GPU hardware during inference. Second is AWQ. I absolutely love this method. Think of a neural network like a house. AWQ is smart enough to identify which parameters are the load-bearing walls. It aggressively compresses the unimportant stuff, but preserves a tiny percentage of the most vital weights. This drastically reduces that dumbed-down effect you usually associate with 4-bit compression. And third is QAT, or quantization-aware training. This is the holy grail, honestly. Instead of building a massive model and squishing it down later, QAT trains the model from the ground up to handle low-precision math. It is born and bred for the edge. Actually, that's exactly what Meta did with LLaMA 3.2.
Section 4, the smart routing strategy, cloud versus edge architecture.
So, how do we bring this all together? Because you definitely don't have to fire your cloud provider. Top tech companies are using a hybrid approach. I really love this analogy because it makes the whole concept instantly intuitive. Think of your AI architecture like a hospital ER triage system. When a patient walks into the ER, they don't immediately see the chief of surgery, right? They see a triage nurse who rapidly assesses the situation. In our tech stack, the edge SLM is your triage nurse, and the massive cloud LLM is the chief of surgery.
Here's the sequential flow of what your modern AI workflow should actually look like. Step 1 is the local triage, where the edge SLM directly intercepts the user's prompt. Step 2 is the heavy lifter, handing only the most complex tasks up to the cloud LLM. Let's break down exactly what happens at each step in real time.
Okay, so in step 1, a user submits a prompt to your application. Instead of hitting the expensive cloud, the query is intercepted by a 4-bit quantized SLM, like our 5.4 Mini, running locally or on a highly affordable edge node. And what are its duties? Well, it evaluates the intent. Does it just need to format a date? Does the prompt contain sensitive data, maybe a social security number or private company data? The SLM handles the simple task, strips out any personally identifiable information to maintain absolute privacy compliance, and returns the answer. The best part of all this? The API cost is exactly $0. Zero. And the latency is completely unnoticeable. We're talking mere milliseconds. But what if the user asks a highly complex question? Well, that brings us to step 2, the heavy lifter. If a query requires massive context windows or deep, multi-step reasoning, the edge SLM realizes, hey, I am simply out of my depth here. But here's the genius part. It seamlessly and securely hands the pre-formatted, completely anonymized data over to a frontier model like GPT-4o or Claude 3.5. The cloud model, acting as our chief of surgery, does the heavy lifting and sends the brilliant answer back down. By implementing this exact dual-layer smart routing strategy, the results are simply staggering. Client engineering teams are routinely pushing 80% of their daily traffic away from premium cloud APIs. 80%. That is huge. That means SaaS margins recover instantly, your applications feel snappy, responsive, and lightning fast for the user. And maybe best of all, your legal team breathes a massive sigh of relief because sensitive US user data never leaves the local device unless it is absolutely necessary. You see, the API tax is no longer a strict requirement of doing business in the AI era. It's a choice. And in today's hyper-competitive tech ecosystem, it is a choice you simply cannot afford to make. Which leaves us with one final, very important question to reflect on. Are you still paying the API tax? Are you currently running all your routine AI tasks through the expensive cloud? Or are you ready to start experimenting with local SLMs to totally optimize your tech stack? It's time to escape the tax, bring intelligence to the edge, and architect the future. Thanks for tuning into this explainer.